Okay, so very good afternoon to all. I welcome you all this today's lecture of our subject industrial hydraulics and pneumatic. Okay, in the last lecture we have discussed the types of the pump. Okay, hydraulic pump, and let me give some highlights on the pumps. Okay, so depending on the construction, we have seen that there are the different types of the pumps. Okay, like a gear pump. So again, in that gear pump, we have seen the external gear pump, then internal gear pump, globe pump. Okay, then screw type pump. Okay, sorry, geo rotor pump. Okay, it's a construction working we have seen. Okay, now another type of the hello. Okay, so I was talking about the types of the pump. So after gear pump, we have another, that is another type, vane type pump. Okay, vane pump. Okay, that today we will discuss. Getting it? Now, before going to the vane pump, the video which we want to see in the last lecture, no, so that will see. Okay, animation about that working of the external and internal gear pump, that we will see, and then I will start with the this vane type pump. Okay, within 1 minute I will share the video.
Rotary pumps. There are 4 types of rotary pumps: screw pump, gear pump, lobe pump, vane pump. In screw pumps, it is the intermeshing of the threads on the rotors and the close fit of the surrounding housing that creates one or more sets of moving seals in a series between the pump inlet and outlet. These sets of seals or locks, as they are sometimes referred to, act as a labyrinth and provide the screw pump with its positive pressure capability. The successive sets of seals form fully enclosed cavities that move continuously from inlet to outlet. These cavities trap liquid at the inlet and carry it along to the outlet, providing a smooth.
Whether voice of video is audible at your end, and this video voice is audible. Okay, in chat box say yes, no, and whether video is visible at your end. Okay, okay.
Flow. The pump is so named because it has 2 gears that are side by side or external to each other. A drive gear that is driven by a motor rotates an idler gear in the opposite direction.
See, so last time we have seen this construction. Okay, so from this one pipe you will get the inlet fluid. Okay, so due to that inlet fluid, this drive gear will rotate. Okay, and this drive gear and this idle gear both are meshed with each other. Okay, so when drive gear will move, or when this drive gear will rotate due to this inlet fluid, no? So due to that only this idle gear also rotate. Okay, you can check. See.
When the gears rotate, the liquid which is trapped in the gear teeth spaces between the housing bow and the outside of the gears is transferred from the inlet side of the pump to the outlet side of the pump. The meshing of the gears on the discharge side of the pump forces the liquid out of the pump and into the discharge piping. The lobe pump receives its name from the rounded shape of the rotor radial surfaces that permits the rotors to be continuously in contact with each other as they rotate. Lobe pumps can be either single or multiple lobe pumps and carry fluid between their rotor lobes much in the same way as a gear pump does. Unlike gear pumps, however, neither the number of lobes nor their shape permits one rotor to drive the other, and so all true lobe pumps require timing gears. Vane pump includes a rotating cylinder containing equally spaced radial pistons arranged radially around the cylinder center line. A spring pushes the pistons against the inner surface of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid during half a revolution and drive fluid out during the other half. The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are: gear pumps handle more viscous fluids. The sliding vane pump suits both viscous and non-viscous fluids. Sliding vane pumps cannot handle dirty or gritty liquids. Vane pumps are ideally suited for low viscosity, non-lubricating liquids. Sliding vane pumps are used for vacuum services. Lobe pumps are used for food and beverage processing. Lobe pumps can handle both low and high viscosity fluids.
Okay. Now I will show another one. Okay, which was remaining. Okay, this is another one video. Okay, in this video,
many different types of pumps exist to assist fluid movement in a variety of systems. An external gear pump uses two gears rotating against each other to provide fluid movement. One gear is driven by a motor connected to a shaft. This is called the drive gear because it is driven by a motor, and it in turn meshes with and drives the movement of the second gear. As the gears rotate away from each other and come out of mesh, they create an expanding volume on the inlet side of the pump. This creates a vacuum at the inlet port, allowing fluid to flow into the pump. Then fluid flows into the cavities and is trapped by the gear teeth. As the gears rotate, a flow path is created around the outside of each one. Fluid trapped in the slots between teeth is carried around and discharged into the cavity with the outlet port. Meshing of the teeth in the center of the pump seals the outlet port from the inlet port. No fluid passes between the gears. The advantages of external gear pumps are their high speed and pressure, relatively quiet operation, and that their design accommodates a wide variety of materials. Disadvantages include bushings in the liquid area can become worn and that they have fixed end clearances. Internal gear pumps are exceptionally versatile. This type of pump has one inner gear which is inside a second outer gear. The inner gear has a shaft driven by a motor and has teeth that protrude outward. The outer gear has teeth that protrude inward toward the center of the pump. As the inner gear rotates, it meshes with and moves the outer gear. Liquid is trapped in the gear spaces and carried from the inlet to the discharge. A stationary crescent-shaped divider separates the intake and discharge portions of the fluid. Advantages of internal gear pumps are a smooth and almost pulseless flow, and slightly more horsepower for its size. Disadvantages are its higher cost, limited size range, low to moderate pressure ratings, and few sources of manufacture. A rotary vane pump is a positive displacement pump that consists of vanes mounted to a rotor. The vanes are on an off-center drive shaft. As the shaft rotates, the variable length vanes slide in and out to maintain contact with the pump housing. The tension in the vanes is maintained by either springs or hydraulic pressure. As the vanes rotate, they create chambers of varying sizes within the pump. Fluid enters at the largest chamber. As the vanes rotate and retract, the chambers get smaller, forcing fluid to exit through the discharge port. The advantages of vane pumps are that they can handle low viscosity fluids at relatively higher pressures, can dry run for short periods, and develop a good vacuum. Their disadvantages include complexity and their unsuitability for both high pressure and high viscosity fluids. Piston pumps come in many different forms. A swash plate is a device used to translate the motion of a rotate shaft into the reciprocating motion of a piston. Swash plate piston pumps have a rotating shaft connected to a cylinder block containing pistons, which are pressed against a stationary swash plate that sits at an angle to the cylinder. As the shaft rotates, the pistons move against the swash plate, causing them to reciprocate within the piston block. The pistons create a vacuum that forces fluid in during half a revolution and expels fluid during the other half. On the intake stroke, a spring ensures the pistons pull back and maintain contact with the swash plate, causing fluid to fill the empty cavity left behind. On the discharge stroke, the angle of the swash plate forces the pistons back inside the piston block and discharges the fluid. The greater the slant on the swash plate, the further the pump pistons move and the more fluid they transfer. Piston pumps, in general, are manufactured with closer internal fits than other pumps. This means that internal slippage can be less so that they operate with reasonable efficiency at pressures both too high or too low for the operation of other pumps. Radial pumps are designed so the pistons stroke in a direction at right angles to the shaft. The pistons are arranged like wheel spokes around a cylinder block with an eccentric central cam mounted on a drive shaft. As the shaft rotates, the cam moves towards the pistons, forcing them down into the cylinder block and discharging the fluid. As the cam moves away, springs help retract the piston and cause the intake stroke. Check valves ensure that fluid only enters the inlet ports and only exits the outlet ports. Radial piston pumps have a low noise level, very high loads at low speeds, and high efficiency. Hand pumps are used when a source of power is not available or where the extra expense of a power pump isn't warranted. For example, they are used on shop presses and other portable equipment, serve as standby pumps, and serve as sources of emergency power. Hand pumps are always of piston type and are usually constructed with a piston working between two check valves. Double-acting hand pumps are more efficient, allowing fluid to both enter and discharge on both strokes of the piston. Moving the pump handle in either direction allows fluid to be drawn in from the reservoir and discharged via the outlet ports. Check valves in all locations prevent fluid backflow.
Okay, so this was just the highlights of the points or the types of the gear pump which we have discussed in the last lecture. Now today we'll discuss the another type of the pump, that is a wind pump. Okay, last time we have discussed the gear pump. Okay, those who have missed this lecture, for them I will repeat once again. The hydraulic pumps are classified into the two types. One is a positive displacement pump, and another type is a non-positive displacement. Okay, in positive displacement pump we'll have the rotary pumps and the reciprocating pumps, and again rotary pumps are sub-classified into the gear pump and wind pump. And under gear pump we have discussed the external gear pump, internal gear pump, lobe pump, jaw rotor pump, and screw pump. Okay, these are the five gear pumps we have discussed. Now today we are going to discuss the another type of the rotary pump, that is a wind pump. And under that wind pump we are going to discuss the two types of the pump. One is the balanced wind pump. Balanced means also that balanced wind pump. It is also known as the fixed displacement pump. Okay, fixed displacement only. And another second type of the wind pump is the unbalanced wind pump. It is also known as the fixed or variable displacement pump. In the balanced wind pump, displacement is fixed only, but in unbalanced pump, displacement is sometimes fixed or it is variable. Getting it? So that part or that type of the pump we'll discuss first, and then we'll go for the another type of the positive displacement pump, that is a reciprocating pump. And in that we will discuss the axial piston pump and radial piston pump, and then we'll discuss the difference between the positive displacement pump and non-displacement pump. Getting it? Okay, let us discuss the variable type displacement pump. Okay, on the screen I have shared the diagram of the vent type pump. Okay, vent type pump. Okay, so as we know that the major problem in the gear pump, okay, the major problem in the gear pump is that the what are the significant amount of the leakage is there, no, which occurs between your small gap of the teeth, gear teeth. Okay, the leakage which is in between the small teeth of the gear, no. So due to that problem, we need to go for the another one gear. Oh, sorry, another one pump. Okay, because the leakage between the your gear teeth, okay, and the your that housing pump housing. Okay, so due to that only need to go for the another type of the pump, and the another type of pump is the vane pumps. Okay, so these vane pumps are the devices, okay, which control the leakage, okay, by using the it's the springs or the hydraulic loaded vanes, okay, hydraulic loaded vanes or the spring. Due to that only vane pumps can control the leakage which were occurring in the gear pump. Okay, now as I have discussed that vane type pump, it's having the two important types. One is the unbalanced vane pump, and second is the balanced vane pump. Okay, now for balanced vane pump, the in that displacement is fixed, but when unbalanced type vane pump, in that sometimes you will get the fixed displacement, and sometimes you will get the variable displacement. So accordingly, that unbalanced vane pump also having the two subtype. One is the fixed displacement unbalanced vane pump, and another variable displacement unbalanced pump. Okay, so firstly we'll go for the unbalanced type vane pump. Okay, and it's a diagram I have shown here. Okay, just check. One minute. Okay, so the figure I have shown on this slide is the unbalanced type vane pump. Okay, so in this pump, what are the rotor is there? No, so that is mounted of in the center only. Okay, mounted of the center. You can check here is our rotor is there. Okay, you can check rotor is there, and at regular intervals. Okay, at the regular intervals around this curved surface of the rotor. No, so that curved surface of the rotor are actually rectangular veins are there. Okay, rectangular veins. So you can see these are the rectangular veins. Okay, that are free to move in a radial slot. Radial slot means this one. Okay, so and as this rotor revolves, no, so that time the veins are through outward direction. Okay, in outward. How it is going to throw outward? Because of the central force, which will form the cells against that your fixed casing. Okay, fixed casing also here I have shown. Okay, and this eccentricity of this revolving rotor, no, so that will produces the partial vacuum at the surface side of this pump. Okay, at the surface side of the pump, and due to that cause, inflow of the liquid will start. Okay, inflow of the liquid will occur, and this is carried to other side of the your pump also. What are the fluid is going to come inside now due to the central pump, due to the partial vacuum which is created at the suction side of the your pump, no, so that will flow in this outside side. Okay, out this one. Okay, outlet. Okay, and this side means the between your rotor and the fixed casing, between your rotor and the fixed casing. And generally what happened is pumping rates is there, no, so that pumping rates of this rotary pumps are varied by changing the speed of the rotor. Okay, by changing the your speed of the rotor, the pumping rate will change. Okay, but in this unbalanced vane type of the pump, what are the pumping rate is there, no, so that can also be varied by changing your the degree of the eccentricity of the your rotor. Okay, degree of eccentricity of the your rotor, if it changes, then your pumping rate is going to change. Okay, and since due to that only the determination of the amount of liquid which is carried through the per cycle, that you can calculate. Okay, so that is a unbalanced type vane pump. Okay, here is the balanced type is shown. Okay, this one balanced type. Now see, one thing is remaining to explain here. Here in this unbalanced type of the vent pump, no, here also we'll have the fixed displacement unbalanced pump and variable displacement unbalanced pump. And in the first type, that is the in fixed displacement unbalanced pump, no. So in that, what are the rotor housing eccentricity is there, no? So that is constant. Rotor housing eccentricity is there, no? That is constant in the fixed displacement unbalanced type of the vent pump. So due to that only, what are the displacement volume is there, no? That you will get the fixed. Okay, displacement volume is a fixed in the fixed displacement unbalanced type of the vent pump. And the what are the constant volume of the fluid is there, no? So that is going to discharge during the each revolution of the your rotor. Okay, what are the constant volume of the your liquid is there, no? So that is going to discharge when during the each revolution of the your rotor. Okay, so that is the difference in the fixed displacement unbalanced type of vent pump. And another is the variable displacement unbalanced type vent pump. So in that variable displacement unbalanced vent pump, so that can be provided, that variable displacement, so that can be provided if the your housing can be moved with respect to your rotor. Okay, if housing, if you can move with respect to your rotor, that time you will get variable displacement, getting it. And this movement can change your eccentricity and of the your rotor, as well as it will changes the displacement. Due to that only it is called variable displacement type vent pump, getting it. And usually our hand wheel or a pressure compensator is there, no? So that can be used to move the cammering, okay, to move the cammering, to which you can change the due to which you can change the eccentricity of the your rotor, getting it. So that is a small difference between the variable displacement and fixed displacement, getting it. Now this balanced, okay, so talking about this balance, no. So here I have shown the image figure of the balanced type vent pump. Okay, so unlike in our unbalanced vent pump, this balanced type vent pump has a two intake. You can see it has a two intake and two outlet ports are there. Two intake, that means the inlet ports are there. You can see two, that is green. Okay, so these are the two intake ports are there, and these are the red are the two outlet ports are there. Okay, which are diametrically opposite to each other, you can see. Okay, diametrically there is both inlet port and outlet port, both are diametrically opposite to each other. And also in this balanced vent pump, it has the elliptical housing. Okay, elliptical housing, you can check elliptical housing it has. Okay, so instead of the circular cammering, okay, which was present in the unbalanced type vent pump, here elliptical housing is there. Okay, and this configuration, okay, this one, so this configuration creates two diametrically opposite volume. Okay, diametrically opposite volume that can that will be created. Okay, due to that this configuration. Okay, okay, and thus what are the two high pressure zones are there now, so that can balance your force on your rotor shaft, and due to that only, or hence due to that, complete hydraulic balance you can achieve. Okay, hydraulic balance you can achieve, and due to that only it is named as balanced type vent pump, getting it. And in this figure you can check the operation of the balanced vent pump I have shown. So except the above, what are the things I have told, no? So that elliptical housing instead of the circular cammering, and diametrically opposite to each other, that inlet and outlet. So what are the construction and the basic working of this basic principle of the balanced and unbalanced? Everything is same. Okay, here it is somewhat difficult to understand from the figure. Okay, for that purpose I will show one small animated video so that you will get the point. Okay, because just you can see here we have the two inlet port. Okay, inlet is there, and here this red color, these are the outlet. Okay, and both are diametrically opposite to each other. Okay, and what are the this balanced vent pump is there? No, so it has the elliptical housing. Okay, elliptical housing is there. Getting it? Okay, so that is a point. Okay, I will show one small video so that you will understand the how it works. Okay, just wait. Here we have one.
Suitability for both high and smaller in contact with the pump housing. The tension in the vanes is maintained. Cost, limited size range, consists of vanes mounted to a size range, low to moderate pressure ratings, and few sources of manufacture. A rotary vane pump
One minute.
Many different types of pumps exist to assist fluid movement in a variety of systems. An external gear pump the chambers get smaller. A rotary vane pump is a positive displacement pump that consists of vanes mounted to a rotor.
Okay, so this is the actual animated image of the our rotary vane pump. Okay, so you can see. Okay,
The vanes are on an off-center drive shaft. As the shaft rotates, the variable length vanes slide in and out to maintain contact with the pump housing. The tension in the vanes is maintained by either springs or hydraulic pressure. As the vanes rotate, they create chambers of varying sizes within the pump. Fluid enters at the largest chamber. As the vanes rotate and retract, the chambers get smaller, forcing fluid to exit through the discharge port. The advantages of vane pumps are that they can handle low viscosity fluids at relatively higher pressures, can dry run for short periods, and develop a good vacuum. Their disadvantages include complexity and their unsuitability for both high pressure and high viscosity fluids. Piston pumps come in many different forms. A swash plate is a device used to translate the motion of a rotate shaft into the reciprocating motion of a
Okay. Now, here also I have another.
Rotary pump. There are 4 types of rotary pumps: screw pump, gear pump. The vane pump includes a rotating cylinder containing equally spaced radial pistons arranged radially around the cylinder center line. A spring pushes the pistons against the inner surface of an encircling stationary ring mounted eccentric to the cylinder. The pistons draw in fluid.
Now see how inlet fluid is taking inside that pump and outlet, and how that vanes are moving. Okay, that you can check here.
During half a revolution and drive fluid out during the other half. The greater the ring eccentricity is, the longer the piston stroke and more fluid they transfer. Applications of rotary pumps are:
Understood or not? Understood? Another one small video I will show. Okay, about the vane pump. That variable and both.
In
So
this,
in this video,
I explained the various types of the vane pump. Generally, there is a 3 types of the vane pump. First one
This
is
is
the
the one-
unbalanced, second one is the balanced vane pump, and third one
Listen.
is the variable displacement vane pumps. So you already studied a vane pump in your fluid mechanics subjects, okay? But I explained the vane pump in the details and why its name is unbalanced, what is the meaning of balance, and what is the meaning of variable displacement. If you know these 3 words, then you can easily able to understand these 3 types of the vane pump. So first we understand unbalanced vane pumps. Okay, this unbalanced vane pump is same that you study in your fluid mechanics subjects. Okay, just we revise it. The vane pump is consist of the cylindrical rotor, which is mounted with an offset inside a circular casings. Now here you see this blue color portion is the rotor. Okay, and this rotor is fitted at a offset to the casing. Now where is the casing? Here you see this is the casing, red portions. Okay, and what is the centers of this casing? Center of casing is slightly here. Okay, but center of the rotor is here, means there is some distance between the center of the casing and the center of the rotor. It is called as the offset. Means rotor and casing have the not the same centers, but it have the different centers. It is called as the offsets. Here you see this the liquid or oil is enter from this side. Here the inlet is mentioned. This is the outlets. Okay, and here this is the van slots, cylinder block and the rotor block, and this side is called as the left side and this side is called as the right sides. The van are seated in a radial slot of the rotor and hold against the casing by spring force or a hydraulic force. Now for understanding these vans, I show you this another image. Here you see this is the rotors. Okay, rotor means this part is our the rotors, and in a rotor they are provide the various radial slots. Okay, so we know that from the centers we go toward the periphery. It is called as the radial directions. Okay, this is called as the radius. Distance from the center to periphery, it is called radius. So this is also called as the radial. So here you see that's the total 8 slot is provided. For example, in this rotor I give only the 1 slots. Okay, so here you see this in diagram. This is the 1 van or a 1 slots. This second, third, fourth, fifth, sixth, seventh and 8th slot is there. Okay, But for example, here I show it is only one slots. Means here in a cylindrical rotors, the one slot is provided, and inside the slot here you see that is a blue color is the van, and this blue color van is moving insides and outsides due to the spring force or a hydraulic force. Okay, here you see that is a different 8 van is there. Okay, this hole is called as the van slot. Here white color portion is van slot and the blue color portion is van. In a van pump image, here you see this black color portion is the various vans. Okay, these van have the same height, but inside the slot you see that is a different position is there. Okay, here the van is the maximum out, here the van is the maximum insides. Okay, why these things are required? These things are making the various pocket size. Here you see is the pocket size is small, here pocket size is larger, here pocket size is larger. This pocket size and this pocket size is same. Then again size is reduced to the delivery sides. Okay, we need to increase the pressures. For increasing pressure we need to know the reduced area. Okay, that means the left side is the suction side, that's why here the left side is mentioned, and this right side is the delivery side. So here you see in a delivery side the area is reduced, that means the pressure is increased. Hence there will not be any leakage of oils between the van tip and the casings. Okay, we know that this is the casing surface and this is the van tip. Okay, this portion is called as the van tips. So there is no chances of the leakage between the van tips and the casings. But still there is some leakage of oils between the rotor faces. So these are only the front view. Okay, but when we go on the side views, that is this rotor have some lands. Okay, so then land is called as the face and the body sides, and its volumetric efficiency will be around 95%. That means some leakage of oils between the rotor faces and the body faces, and due to this leakage the volumetric efficiency of the van pump is reduced to the 95%. As the rotor is rotated, size of the pocket is goes on increasing on the left sides. So here you see on the left sides the size of the pocket is increasing, that I already explained. Okay, so this is small size, this is the larger and this is larger, and reducing on the right sides. Here you see on the right side the pocket size is first higher, then after smaller, and then after further smaller is there. So this cause the suction of oil at the left side. So here you see on the left side inlet is there, that means suction is on the left sides, and the delivery of oil at the right side. Difference in pressures between the inlet and outlet ports create a side thrust on the rotor shafts, which is consequently lower the bearing, and due to this the bearing life is reduced. So we know that at the suction side here the pressure is near to the atmosphere, and on the delivery side that is the pressure is higher according to requirement, that is 8 bar, 20 bar, 25 bars. Okay, so this pressure difference is create the some unbalance on the rotor shaft, that is in the term of the thrust. Okay, means thrust on the rotor shaft is different, and due to that the load on the bearing is changing and the bearing life is reduced. Okay, that's why its name is given the unbalanced van pumps. And this problem of side thrust on the bearing is nullified in a design of balanced van. Create the some unbalance on the rotor shaft, that is in the term of the thrust. Okay, means thrust on the rotor shaft is different, and due to that the load on the bearing is changing and the bearing life is reduced. Okay, that's why its name is given the unbalanced van pumps. And this problem of side thrust on the bearing is nullified in a design of balanced van pumps. Means the disadvantage of the van pump is that it have the unbalanced thrust on the rotor shaft, and this unbalanced thrust is solved in a balanced van pump. Okay, so in a balanced van pump there is the same thrust on the rotor shaft, that's why it is called as the balance. So in unbalanced, why its name is unbalanced? Due to the different side thrust on the rotor shaft. Now we move towards the balance. Before moving ahead, I request to like the video and subscribe my channels for watching the more video related to the OHP as well as the other subject. Balancing the side thrust, they provided 2 inlet and 2 outlet. In earlier we see that only 1 inlet and 1 outlet is there. But now in this image you see this inlet is provided on these 2 sides and outlet is provided on these 2 sides. Due to these 2 inlet and 2 outlet, the side thrust is the balance. That's why its name is given as the balanced vent pump. In this type of the pump, 2 inlet and 2 outlets are used. Due to this, the equal and opposing side thrust get balanced. And hence, this type of the pump is give the better service and the longer life. The center axis of the rotor and that of the electrical casings are the same. So here you see this electrical casing is used. Okay, in earlier case that is a casing shape is different, but here we use the electrical casing. Okay, because it have the 2 inlet and 2 outlet. So center axis of the rotor means this is the rotors, and the center axis of the rotor, that of the electrical casings are the same. Means here no offset is used. Okay, the center of the casing and the center of the rotor are same. In unbalanced, what we studied, that is some difference between the center of the rotors and the center of the casings. But in a balanced vent pumps, the center of the rotors and the center of the casings are same. Why it is same? Because in this case we use the electrical casing. In a unbalanced, we use the circular casing. As the rotor rotates, the size of the pocket goes on increasing on the one side and reducing on the another side. So in this case we need to divide from these sides. Okay, these are our axis, means we from the 45 degree we consider. Okay, so here the smaller size, then larger and larger, and then after increasing. These cause the suctions of the oil at the inlet and the delivery of oils at the outlets. So here you see that here the inlet is that. So first the pocket size is increasing, then again here from reducing, that's why here the outlet is there. From this side inlet is there, you see this pocket size is increasing, and here outlet is coming, then the pocket size is just start to reduce. That's why the electrical shape is used. Suppose we use the circular shape here, then we are not able to achieve the 2 inlet and 2 outlets. For achieving 2 inlet and 2 outlet, we need to make the electrical shapes of the casings. Now the third one type is the variable displacement vent pump. Now what is the variable displacement vent pump? Variable displacement means that is a change in the pocket size. Okay, and change in the pocket size is give the variable displacement, and due to variable displacement we are able to get the variable discharge from the vent pumps. Now for achieving the variable displacement pump, we need to add the certain components in earlier unbalanced type of the vent pumps. So here you see these are the rotor. In a rotor various slot is provided, and in this slot van is there. Okay, now van is not directly contact with this casing, this part is the casing. Okay, but in between the casing and van you see the one ring is provided. This ring is called as the reaction ring. Okay, so here you see this is the reaction rings. Now one side the reaction ring is connected with this adjusting screw, and another side this reaction ring is connected with this spring. Okay, and this part is the casing, and we see that it is the left side and the right sides. This pump is consist of cylindrical rotor with radial slots inside the reaction rings, and vents are inserted in the radial slot. This sentence is common in all the 3 pumps. Okay, as the rotor is rotated, size of the pocket goes on increasing on the left side and reducing on the right side. Same way here you see on the left side the pocket size is increasing, here small, this is larger, this is larger, this is larger. Okay, then after on the right side the pocket size is start to reducing, here you see the pocket size is reducing. This cause the suctions of oil at the left sides and delivery of oil on the right side. Means this side the suction is provided, but in this image we are not able to see where is the suction and delivery. Okay, so here somewhere the suction is provided on these sides and here the delivery is provided, but in this image they are not mentioning the suction and discharge sides. Adjusting screw is provided to vary the reaction ring and the discharge. Now here you see this adjusting screw is provided. Okay, by changing the adjusting screw we are able to changing the pocket size of the reaction ring. By turning the screw, the reaction ring can be moved up or down. So when we tighten this screw, the reaction ring is moving in upper directions and the size of the pocket is reduced. This causes the offset between the rotor centers and the reaction ring centers to change. Means by turning the screw, we are able to change the offset between the rotor centers. So this is the rotor centers and somewhere here the reaction ring centers. Okay. So by turning the screw, we are changing the offset distance between the reaction ring and the rotors. And when the offset is changing, the pocket size is also changed. By changing this offset, we can change the pocket size. By changing the pocket size, the discharge is also varied. So we know that when the pocket size is reduced, then discharge is lower, and when the pocket size is increased, the discharge is higher. So thank you for watching this video. If you learned something, then like.
Okay, sorry, my wife. I have mute myself. So this was the about the vent type pump. Now remaining two pumps, that is piston type pump, that we will discuss the tomorrow. Okay. So I request all of you, please write your roll number in the chat box, and after writing your roll number in the chat box, you can leave this meeting. Okay. So thank you very much. See you tomorrow. Remaining students, please write down your roll number. सोंडके पिसे ऋतुराज काळे रोहित जुंजळे.